Good day. My name is D.J.S Robles of BS-ECE3A, and I will discuss to you about the T flip-flop. But before that, let's define first what is a flip-flop. So, what is a flip-flop? It is a device which stores a single bit binary digit of data. One of its two states represents a 1 or high and the other represents a 0 or low. Such data storage can be used for storage of state, and such a circuit is described as sequential logic in electronics. So let's proceed to the T flip-flop. So the T flip-flop is also known as the toggle flip-flop. To avoid the occurrence of intermediate state in SR flip-flop, we should provide only one input to the flip-flop called the trigger input. That is why it is called the toggle flip-flop. Then, the flip-flop acts as a toggle switch. So as you can see in the T flip-flop diagram, we have here the T, which is the toggle input or the trigger input. We have also the clock, the output Q, and the output Q prime, which is the inverse of our output Q. Toggling means changing the next state output to the complement of the present state output. Let's have here characteristic table of the T flip-flop. So, as you can see, the value of our input when T is equal to 0, our Q next is equal to Q. When our T is equal to 1, our Q next is equal to Q prime. So we have here our characteristic equation for the T flip-flop. So the characteristic equation of our T flip-flop is given by Q next is equal to the trigger input multiplied to the Q prime plus our trigger input prime multiply to Q. Again, when the trigger input is equal to 0, which means this would be equal to 0, our Q prime, this would be equal to 0 multiplied to Q prime plus 1 multiplied to Q. So we cancel out, and which is left is Q. And so, when T is equal to 1, then our Q next is equal to Q prime. Let's have our circuit of the T flip-flop using the NAND SR latch. We have our T here connected to the both NAND and also a clock. We have also here an input coming from our Q prime and an input here coming from the Q. And here we have also here the input coming from the NAND here, an input here coming from here, another input coming from the Q, and another input here coming from the Q prime. Well, let's have the table, the excitement table of the T flip-flop so that it will be easier for us to read the circuit. Let's have a look here. So as you can see, if the output Q is equal to 0, then the operand is in enable state. The upper NAND here is in enable state, and the lower NAND is in disable state condition. This allows the trigger to pass the set inputs to make the flip-flop set, and the state Q is equal to 1. If the output Q is equal to 1, then the upper NAND is in disable state and lower NAND is in enable condition. This allows the trigger to pass the reset inputs to make the flip-flop reset Q is equal to 0. In simple terms, the operation of the flip-flop is when the input is low, or that the trigger input is equal to 0 here, the next state of the T flip-flop is the same as the present state. So when T is equal to 0 and your Q is equal to 0, then the next state of your output will be equal to 0. Furthermore, when T is equal to 0 and your Q is equal to 1, then the next output state is equal to 1. On the other hand, when our trigger input is in a high condition, or T is equal to 1, then the next output will be the reverse of the previous output. So when T is equal to 1, Q is equal to 0, the next output Q is equal to 1. And when T is equal to 1 and Q is equal to 1, then the next output is equal to 0. As each incoming trigger alternately changes the set and the reset inputs, the flip-flop toggles. So complete one full cycle of the output waveform, it needs 2 triggers. This means that this flip-flop produces the output at exactly half of the frequency of the input frequency. So the T flip-flop will act as a frequency divider circuit. So the frequency divider circuit is one of the application of our T flip-flop. However, the main disadvantage of the T flip-flop is that the state of the flip-flop at an applied trigger pulse is known only when the previous state is known. So as you can see, this circuit is made up of NAND gates. So this is the circuit of, or the logic equivalent of the T flip-flop derived from the JK flip-flop. As you can see, this is also a master-slave JK flip-flop. However, we have set some additional parts like the preset and the clear. So when the preset here is equal to clear, which is equal to 1, let's have that. As you can see, the indicator is blinking, which means that the asynchronous inputs are inactive, and the FF is free to respond to the values of JK, or the value of the trigger, and the clock inputs. In other words, the clock operation can take place. When the preset is equal to 0 and clear is equal to 1, the preset is activated and Q is immediately set to 1 no matter what conditions are present. So the clock input cannot take effect while preset is equal to 0. As you can see, the value of the Q here stays stagnant while the Q prime is blinking. And then, when the preset is equal to 1 and clear is equal to 0, the clear is activated and Q is immediately cleared to 0, independent of the conditions of the other inputs, and the clock input has no effect while clear is equal to 0. So when the preset and clear is equal to 0, the condition should not be used because it can result an ambiguous response. As you can see, Q and Q prime is equal to 1, which is not right because Q prime is the inverse of Q. Thank you so much. My name again is D.J.S Robles of BSPCE 3A. And thank you for listening. See you.